Okay, hello everyone. My name is Tanawat Rerkrachaneekorn. Today, I would like to present about my terms paper in the topics of palladium-catalyzed intermolecular additions of alkyne for synthesis of polyaromatic and heterocyclic compounds. I will introduce a little bit about the palladium. Palladium is a value transition metal in group 10, period 5. A common oxidation number of palladium is 0 and +2. In addition, the geometry of palladium-2 complex is aware square partner due to the most stable form when filling the H electron. However, it is a catalyst in many important reactions such as Heck, Stille, Sonogashira, Suzuki, Negishi, and Vega process. How is alkyne important? The reactions of alkyne with other starting materials belong to the foundations of various applications such as material science and core structure of biomolecules. For the material science, I will talk about naphthalene, phenanthrene, and pentylene. But for the core structure of biomolecules, I will talk about indole, isocoumarine, and phenone, and phenolene. So the topics for this review was divided to two parts. The first one is palladium-catalyzed intermolecular additions of alkyne for the synthesis of polyaromatic. And the second one is the palladium-catalyzed intermolecular additions of alkyne for synthesis of heterocycles. Yeah. Let's start with the polyaromatic topic. In 2007, Liu and Laloc published a method for synthesis of the phenanthrene. As I shown you, for the optimization, they used for ethyl 4-iodobenzoate, diphenylacetylene, and benzene as the starting material. Use the palladium-2 as a p-catalyst, thorium acetate and cesium fluoride as an additive in 1:1 co-solvent between acetonitrile and toluene, and 90 degrees Celsius for 8 hours. And they obtain the product in 86%. However, the substate scope have done with 16 examples from 49 to 91%. For the purpose mechanism, firstly, the oxidative addition between palladium and allyl halide occur the intermediate A layer, and then the intermediate A will coordinate with alkyne to generate intermediate B, and B can take an addition to form intermediate C, which intermediate C can take an addition again with the another alkyne to generate the intermediate H, or C undergo the carbopalladation with benzene, which came from the elimination from the cesium fluoride to give an intermediate H. Both E and H will occur the reductive elimination to obtain the product F and product K. However, the researcher cannot detect the product F in this reaction because of the steric hindrance from the two phenyl group as I circle in the intermediate D. The second one is in 2008, Wu and co-worker demonstrated the synthesis of naphthalene. Yeah, and the optimization condition contains of silver acetate, palladium acetate, dissolved in paracyrene, and diphenylacetylene dissolved in acetonitrile. And the experiment was set up at 110 degrees Celsius for 36 hours under nitrogen temperatures. However, they obtained the product in 60% with optimized condition. And the substate scope have done with 30 examples from 6 to 60%. The mechanism was proposed here. Initially, the electrophilic palladiation between palladium acetate and paracyrene gave the allyl palladium intermediate 7. Next, the intermediate 7 will coordinate with alkyne and occur the syn addition, providing the vinyl palladium intermediate 9. And this addition will be occurred again between vinyl palladium 9 and alkyne to afford the intermediate 8. And the intramolecular palladiation of intermediate 8 occurred and form the intermediate 4, which can undergo the reductive elimination, yielding 3AA or naphthalene as a product at palladium 0. And finally, palladium 0 reacted with the silver acetate to generate the palladium acetate initiator again. And the third one is in 2012, Vidalich performed a construction of pentylene. The researcher obtained the highest yield of the pentylene in 42% by using the germinal ribomoolefin and diphenylacetylene as a starting material. Use the dichloroditriphenylphosphine palladium as a catalyst and zinc powder as a reducing agent. The reaction was carried on 100 degrees Celsius for 20 hours in toluene solvent. And however, the 11 example of substate scope have done from 17 to 42%. And the possible mechanism began with the coordination between palladium and alkyne to give the intermediate A. And second was an oxidative addition between palladium here and bromo here on the intermediate A itself to generate the intermediate B. The intramolecular carbochylation occur and form the fulvene intermediate C here, and follow it the intermolecular carbopalladiation with alkyne to generate the intermediate D. Yeah, and the insertion of palladium here and double bond here of intermediate E will obtain the intermediate F. Yeah, and finally, zinc will assist the formation of pentylene and give a zinc bromide out in reaction. And yeah, now move to the heterocycle topics. In 1998, Rerkrachaneekorn and co-worker shown a synthesis of 2 and 3 disubstituted indole by using 2-iodoaniline dipropylacetylene as a starting material and use the palladium acetate as a catalyst, lithium chloride as an additive, and potassium carbonate as a base. Use the GMF solvent at 100 degrees Celsius for 20 hours. From this condition, they will obtain the product in 80%. And however, the 30 example of substitute have done from the 27% to 98%. And the mechanism of this reaction start with the reduction of palladium 2 to palladium 0. Then the coordination of chloride ion will obtain the chloride ligated zero valence palladium intermediate here. Next was an oxidative addition between that intermediate and aryl iodide to form the intermediate, to form the new intermediate as I circle here. And after that, the coordination between alkyne and the last state intermediate occur and take an addition reaction to form the 6-membered ring intermediate here. And eventually, the reductive elimination occurred from the 6-membered ring intermediate and obtain the 2 and 3 disubstituted indole as a product. And the second one is in 1999, Rerkrachaneekorn and co-worker reported the synthesis of isocoumaline and alpha-pyrrole. The researcher optimized the various factors, and they found that if they use methyl 2-iodobenzoate and diphenylacetylene as a starting material, palladium acetate as a catalyst, triethyl phosphine as a ligand, and use the triethylamine and sodium acetate as a base in GMF solvent at 100 degrees Celsius for 24 hours. They will obtain 3 and 4 diphenyl isocoumaline in 56%. And besides, 40 examples of the substitute have done from 10 to 77%. And the researcher believed that the first step of this mechanism was the reductions of palladium 2 to palladium 0, as I discussed with all of you from the previous paper. And the second one was the oxidative addition between palladium and aryl halide to generate the carbon palladium and halide bond that I circle here. And the insertion of the carbon palladium halide bond with alkyne will be the next step, forming the vinyl palladium intermediate. And the attacking of the oxygen on carbonyl group will attach to the vinyl palladium intermediate to form the 7-membered ring. And the last step was always the reductive elimination, providing the product isocoumaline here and gave a palladium 0 again. in the catalytic cycle. And the last one is in 2011, Shu and Yaman pointed how to synthesize the phenolene by using the palladium-catalyzed of the 2-iodophenyltriazine with the diphenyl acetylene starting material. Another factors were used, such as palladium acetate as a catalyst, tritoluylphosphine as a ligand, and triethylamine as a base in DMF solvent at 90 degrees Celsius for 15 hours. And from this condition, the researcher will obtain the product in 71%. And furthermore, 17 examples of the substate scope have done from 35 to 84%. The first step of mechanism was an oxidative addition between palladium zero and the 2-iodoaryl triazine in situ, leading to the intermediate A. This intermediate can be inserted with the alkyne to generate intermediate B, and intermediate B can undergo the 6-pi electron cyclization to form an intermediate E. Next, the beta amino on the intermediate E can be eliminated to obtain the phenolene product and obtain the ethyl amino palladium G. That can occur the beta elimination to obtain the palladium zero here. And however, this mechanism has the other pathway as well. For the another pathway, another pathway was the coordination of the triazine group and finally palladium position of intermediate B to generate the 7-membered ring intermediate C. Then it generated the ammonium salt D and palladium zero via the reductive elimination as well. And finally, the ammonium salt D will afford the phenolene product 3 from the protonation in the presence of base. In conclusion, this will illustrate the use of palladium, for catalyze the intermolecular additions for synthesis of polyaromatic and heterocyclic compounds with 3 main steps, such as oxidative addition, insertion, and reductive elimination, respectively. Thank you for your kind attention. Bye-bye.